And welcome back to Master Your Science channel. We'll be continuing with our Master Your Chemistry series, and we'll now be looking at the IGCSE Chemistry Topic 2, Atoms, Elements and Compounds. Please note that this is part 2. You can check for part 1 in the Master Your Chemistry series playlist linked below. Section 2.4, Ions and Ionic Bonds. According to the IGCSE Cambridge syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to: number 1, describe the formation of positive ions known as cations and negative ions known as anions. Number 2, state that an ionic bond is a strong electrostatic attraction between oppositely charged ions. Number 3, describe the formation of ionic bonds between elements from group 1 to group 7, including the use of dot and cross diagrams. Number 4, describe the properties of ionic compounds. Number 5, describe the giant lattice structure of ionic compounds as a regular arrangement of alternating positive and negative ions. Number 6, describe the formation of ionic bonds between ions of metallic and non-metallic elements, including the use of dot and cross diagrams. Number 7, explain in terms of structure and bonding the properties of ionic compounds. All questions that we'll be looking at are taken either from the Cambridge specimen papers or the past exam papers. This question says, which statement describes the bonding in sodium chloride? Sodium chloride is an ionic compound. So it's an ionic compound, and sodium is a metal. Chlorine is a non-metal. As a general rule, this doesn't strictly apply everywhere, because we've got compounds such as ammonium chloride, which is ionic but is made up of non-metals. But as a general rule, ionic compounds form between metallic elements and non-metallic elements, because generally metals prefer to lose electrons. So when a metal loses electrons, it forms a positively charged ion, which we call a cation. And non-metals prefer to gain electrons, and when an atom gains electrons, it forms a negatively charged ion, which we call an anion. So in sodium chloride, sodium will form our cation, and chlorine will form our anion, which is the chloride ion. Sodium is a group 1 metal, and chlorine is a group 7 non-metal. So sodium, being a group 1 metal, will prefer to lose the 1 electron that it has in its outermost shell in order to achieve the noble gas electronic configuration. So it will have a charge of sodium plus. Then chlorine will prefer to gain an electron to achieve the noble gas electronic configuration, because it has 7 electrons in its outermost shell. It gains 1, and then there will be 8, so it will have a negative charge. So when there's a single positive or negative charge, you don't need to write the 1. You just write either positive or negative. So you've got sodium plus and Cl minus for the chloride ion. So these two oppositely charged ions, your sodium plus and Cl minus, will attract each other, and this attraction will be a strong will be as strong electrostatic attraction. So if you've got two oppositely charged ions, there will be a strong electrostatic attraction between them. So going back to our question, it says, which statement describes the bonding in sodium chloride? The first answer says a shared pair of electrons. So in ionic bonding, we don't have sharing of electrons. So that makes this first statement incorrect. Then B says a strong force of attraction between oppositely charged ions. This is correct, as we have just discussed. Sodium plus and Cl minus will attract each other, and this will be a strong electrostatic attraction. So this would be correct. Then the part C says a strong force of attraction between two molecules. This is incorrect. Then a weak force of attraction. This is incorrect. As we've just said, it will be a strong force of attraction. Therefore, the correct answer is B. This next question says, ionic compounds form giant ionic lattices. Figure 2.2 shows part of the giant ionic lattice structure of sodium chloride. Complete the diagram in figure 2.2 to show the ions present. Use plus for sodium ions and minus for chloride ions. One chloride ion has been completed for you. So a lattice simply means a regular arrangement. So ionic compounds will form regular arrangements of alternating positive and negative charges. So in this case, we have the negative here filled in. So this negative ion will be surrounded by positive ions. So this will be a plus, this will be a plus, this will be a plus. Then each positive ion will be surrounded by negative ions. So this will be negative, this will be negative, this will be negative, and this will be positive. This question says magnesium reacts with chlorine to form magnesium chloride. Magnesium chloride is an ionic compound. Complete the dot and cross diagram in figure 2.1 of the ions in magnesium chloride. Show the charges on the ions. So, as we've already stated, a metal and a non-metal will form an ionic compound. And in this case, we've got magnesium, which is a metal, and chlorine, which is a non-metal. Magnesium is a group 2 metal, so it has 2 electrons in its outermost shell, and it will prefer to lose those 2 electrons in the outermost shell, meaning that there will be the electrons will be less compared to the protons by 2. That gives it a positive charge of 2 plus. Whereas chlorine will prefer to gain a single electron in order to fill its outermost shell where it has 7, so it will gain 1 to have 8, so it will have minus. So magnesium loses 2 electrons, but each chlorine atom will only take 1, which means the ratio in which these combine will be just as shown in the formula, which is 1 magnesium is to 2 chlorine atoms, as to 2 chlorine ions. So now we already know we've got a charge of 2 plus for magnesium and minus for chlorine. So let's go and complete the dot and cross diagram. So first off, we'll complete the charges. So it's going to be a charge of 2 plus for magnesium, then minus and minus for the chlorine. The next off, you always have to check whether the number of shells that are shown in your dot and cross diagram agree with what it should be, because it's not only the charges that you need to fill in. So magnesium is in period 3, which means it normally has 3 occupied shells, but it has lost the 2 electrons in its outermost shell, so it will have 2 occupied shells, and that second shell will be full with 8 electrons. So we have only one drawn in for us, so now we have to draw in the second shell and fill it with 8 electrons. And the electrons for magnesium are represented as crosses, so we also have to put crosses in our drawing. Then for chlorine is also a period 3 element, so it will have 3 shells, and chlorine will still have 3 shells because it's gaining an electron to fill the outermost shell. So from what is drawn here, we can see that 2 shells, so we need to put in the third shell, which is full with 8 electrons. So draw in our third shell here. And we have the dots for the 8 electrons that are in the outer shell, and 1 cross to show the electron that has been gained from magnesium. Same for the other chlorine ion. Okay. The question says, one physical property typical of ionic compounds such as magnesium chloride is that they are soluble in water. Give 2 other physical properties that are typical of ionic compounds. So one property is that ionic compounds have high melting and boiling points. And then the second property is that ionic compounds conduct electricity in molten or aqueous state. Ionic compounds do not conduct electricity in solid state. And the reason for this is that when they are in solid state, there are no ions that are moving to carry the charge. But when they are in molten or in aqueous state, the ions are free to move, and these carry the charge. And this next question says, sulfur atoms can form the negative ion S2-. Three other atoms or ions are listed, that is argon, calcium, and oxide. How many of these atoms or ions have the same electronic configuration as S2-? So let's work out the electronic configuration of S2-. So sulfur as an atom has a proton number of 16. So if it forms an ion with the negative charge 2-, it means there are 2 more electrons than there are protons, so it would be 16 plus 2. That would give us 18 electrons. So from 18 electrons That would mean our S2 minus is an electronic configuration of 2.8.8. Then argon, which is in the same period as S2 minus, has a proton number of 18, and that would be also its number of electrons. Being an atom, is neutral, so it would have the same electronic configuration 8.8. And this should be obvious to us because argon is in the same period as sulfur. So when sulfur forms an ion, it will have the noble gas electronic configuration of argon, which is in the same period as it is. Then calcium has a proton number of 20, so its electronic configuration would be 2.8.8.2. Then the oxide ion O2 minus, oxygen has a proton number of 8, so plus 2 extra electrons, so that means it has 10 electrons, so it would have an electronic configuration of 2.8. So from what we can see here, only argon has the same electronic configuration as sulfur 2 minus. So the question is saying how many of these atoms or ions have the same electronic configuration as S2 minus, so that will only be 1. So our answer is B. This question says lithium is in group 1 of the periodic table, nitrogen is in group 5 of the periodic table. Lithium reacts with nitrogen to form the ionic compound lithium nitride. What happens to the electrons when lithium atoms and nitrogen atoms form ions? So lithium is a metal, so a metal will prefer to lose electrons, and nitrogen is a non-metal, it will prefer to gain electrons. So if an ionic compound is forming between lithium and nitrogen, lithium will lose its 1 electron, which is in the outermost shell, to nitrogen, which is a group 5 element. Nitrogen, being in group 5, will prefer to gain 3 electrons. So in order for it to have the noble gas electronic configuration of 8 electrons in its outermost shell. So let us look at the answers we have here. So A says each lithium atom loses 1 electron to form N lithium plus ion. Then each nitrogen atom gains 3 electrons to form N3 minus ion. So from what we've just discussed, this would make sense. Lithium is in group 1, it loses 1 electron. Nitrogen is in group 5, it gains 3 electrons. Then B says each lithium atom loses 1 electron to form N lithium plus ion. Then each nitrogen atom gains 5 electrons to form an N5 minus ion. This part is incorrect. Then C says each lithium atom gains 1 electron to form N lithium minus ion. Lithium is a metal, it would prefer to lose rather than to gain electrons, so this is incorrect. Then D says each lithium atom gains 1 electron to form a lithium minus ion, so this also makes that incorrect before we have looked at the other part of the answer. So our answer here would be A. And this question is about ionic compounds. State what is meant by the term ionic bond. So an ionic bond is a strong electrostatic force of attraction between oppositely charged ions. So it's a strong electrostatic force of attraction between oppositely charged ions. So the key terms being strong force of attraction and oppositely charged ions. And the next question is asking which pair of elements react to form a compound with a strong attraction between oppositely charged ions. So this question is basically asking which pair of elements will form an ionic compound. And as we said, as a general rule, an ionic compound will form between a metal and a non-metal. So let's look at our answers here. So the first answer says carbon and bromine. These are both non-metals, so this would be incorrect. Then carbon and nitrogen, those are both non-metals, so that would be incorrect. Then this is sodium and potassium. These are both metals, so that is incorrect. So C is the correct answer because it's saying sodium and oxygen, sodium being a metal and oxygen being a non-metal. The next question says, state the name given to any positive ion. So a positive ion is a cation. A negative ion is an anion. Then the next one says manganese is the element with atomic number 25 in the periodic table. Calcium is the element with atomic number 20 in the periodic table. Complete table 5.1 to show the number of protons, neutrons, and electrons in the manganese 55 atom and the calcium 2 plus ion. So manganese being an atom, the number of electrons is going to equal the number of protons, and we have been told that it has an atomic number of 25, so the atomic number is also the proton number. So for manganese there, our number of protons is 25, and being an atom is neutral, so it also has 25. It has 25 electrons. Then to find the number of neutrons, we have to say the mass number minus the number of protons. So that's 55 minus 25, and that gives us 30. So that's it for our manganese. And then for our calcium 2 plus ion, we've been told that calcium has an atomic number of 20, so that's the number of protons, so that's 20. But this is a cation, which means it lost some electrons. So for our number of electrons, that would be 20 minus 2, so we'll have 18 electrons. And then we've got 42 minus 20 to get the number of neutrons. So that would be 22. This question is asking which statement about ions and ionic bonds is correct. A says bromine atoms form negatively charged bromide ions. So this statement is correct. Bromine is a non-metal. It will prefer to gain electrons to form negatively charged ions, which are anions. Then B says ionic bonds form between elements in group 7 of the periodic table. This is incorrect because group 7 elements are all nonmetals, and generally nonmetals will not form an ionic bond between themselves. Then positive ions are formed when atoms lose protons. This is incorrect. Positive ions are formed when atoms lose electrons. Then potassium iodide contains negatively charged potassium ions. This is incorrect because potassium being a metal will prefer to lose electrons and form a cation. So the correct answer here would be A. This next question says part of the periodic table is shown. which type of chemical bonding is present in the oxide of F and the oxide of G? So F is in group 2, so that would imply that F is a metal. So if F is a metal, if it forms an oxide, which means it's forming a compound with oxygen, oxygen being a nonmetal, that would mean that we would have ionic bonding. So that eliminates A and B. Then G is in group 6 of the periodic table. If it forms, which means it's a nonmetal, and if it forms a compound with oxygen, which is also a nonmetal, then we would actually have covalent bonding. So that means D here would be incorrect. So C is the correct answer. Then elements X and Y react to form a compound. Element X loses 2 electrons and element Y gains 1 electron. What is the charge on the ions of element X and Y, and what is the formula of the compound? So if X loses 2 electrons, that would mean it's gaining a positive charge, and that there are 2 less electrons compared to its protons, which means it has a charge of 2 plus. So that would mean our X would have a charge of 2 plus. Then if Y is gaining 1 electron, there will be 1 more electron compared to its proton, so it will have a negative charge. So Y would have a charge of minus. So looking at our answers, that eliminates C and D. And now that we've got our charges, a shortcut to getting the formula of the compound that forms between these two would be this is a shortcut, so the 1 comes to your X, the 2 goes to your Y. Basically, we're saying if you've got 1 Y, which is a negative charge, and an X, which is 2 plus, so if X is losing 2 electrons and Y is only gaining 1 electron, it means we need 2 of Y compared to X. So they should be in a ratio of 2Y is to 1X. So that gives us XY2 as the formula. So that eliminates A, and we've got B as our correct answer. Section 2.5, Simple Molecules and Covalent Bonds. According to the IGCSE Cambridge syllabus for examination from 2026 to 2028, by the end of this topic, you should be able to 1. State that a covalent bond is formed when a pair of electrons is shared between 2 atoms, leading to noble gas electronic configurations. 2. Describe the formation of covalent bonds in simple molecules and use dot and cross diagrams to show the electronic configurations. 3. Describe in terms of structure and bonding the properties of simple molecular compounds. 4. Describe the formation of covalent bonds in simple molecules and use dot and cross diagrams to show the electronic configurations. Generally, covalent bonds will form between nonmetals, and a covalent bond forms when a pair of electrons is shared between 2 atoms such that each atom is able to achieve the stable electronic configuration of a noble gas element. This question says draw a dot and cross diagram to show a molecule of ethene. Show outer shell electrons only. So we've got hydrogen, which has 1 electron in its outermost shell, and then we've got carbon, which is a group 4 element, so it will have 4 electrons in its outermost shell. So let us draw the dot and cross diagram to illustrate how these will bond. Okay, so we'll use crosses for hydrogen and dots for the carbon. We use a different color for the electrons. So one electron will come from the hydrogen and one electron from carbon. So hydrogen will have a full outer shell with 2 electrons in its outermost shell. So that's the noble gas configuration of helium. Then so for show which elements these are, so the same for each hydrogen. So hydrogen cannot have more than 2 electrons. So that's hydrogen. So now looking at each carbon atom here, we see that carbon has used 2 of its electrons to bond with the hydrogen. So it has 2 more electrons left. And it still needs, if we add those 2 electrons to the 2 bonds it has with hydrogen, that puts us to 6. It still needs 2 more electrons in order for it to have a full outermost shell. So it means that carbon will now need to share its electrons with the other carbon atom so that it can be able to achieve its full outermost shell. So if we look now at the electrons that are surrounding carbon, that will be 1, 2, 3, 4, 5, 6, 7, 8 electrons. It has achieved its noble gas electronic configuration, and it has 2 covalent bonds. As you can see from that what we've been given in the question, those 2 dashes represent 2 covalent bonds, and from this drawing here, each pair of electrons is a covalent bond. So this would be the first covalent bond and this would be the second one. So there are 2 covalent bonds between the 2 carbon atoms, and then there is 1 covalent bond to each hydrogen atom. This next question says, for which covalent compound does the dot and cross diagram correctly show the outer shell electrons? So for A, this is definitely incorrect because as you can see, the hydrogen there already has 4 electrons, which is impossible. Hydrogen cannot have more than 2 electrons in its outermost shell. So that also makes B incorrect. And then now looking at the 2 last options that we have, nitrogen is in group 5 and it needs to gain 3 electrons from the hydrogens. So as you can see, the nitrogen indeed does not have a full outermost shell, so that is incorrect. So that leaves us with C, which is correct because each hydrogen has 2 electrons in its outermost shell and the nitrogen has 8 electrons in its outermost shell. This next question says, complete the dot and cross diagram in figure 4.2 of a molecule of carbonyl chloride. Show outer shell electrons only. So you can see we've got chlorine, carbon, and oxygen. Chlorine is a group 7 element, so it has 7 electrons in its outermost shell and it requires 1 more electron in order for it to have a noble gas electronic configuration. so it will only make one covalent bond. Carbon is a group 4 element. It needs 4 more electrons in order for it to achieve the noble gas electronic configuration, so it will make 4 covalent bonds. Oxygen is a group 6 element. It needs 2 more electrons in order to achieve the noble gas electronic configuration, so it will make 2 covalent bonds. So we can expect there to be 1 covalent bond between carbon and chlorine, 1 covalent bond between carbon and the other chlorine, and 2 covalent bonds between carbon and oxygen. So to put in there, so forgive my drawing, but the electrons should be within that intersection. Then here we'll have 2 covalent bonds, so that's two pairs of electrons. So we'll have so 2 pairs of electrons there. And then, as you can see, carbon now has a full outer shell. It's got 8 electrons. Now for chlorine, we need to fill in the other 6 electrons. So quickly fill those in. And then oxygen, we also need to fill in the other electrons, so that will be 4 electrons because it has already used 2 for the bonding. So as you can see, now each atom has 8 electrons around it.